And so, as the world outside settles into its evening quiet, and perhaps the very air around us grows cooler with the fading light, let us begin a journey. A journey not of vast distances or sudden discoveries, but of a slow descent into stillness, a gentle exploration of what happens when motion itself begins to dream. Think, for a moment, of winter, not the harsh, biting cold that demands a hurried retreat indoors, but the soft, whispering kind of winter that wraps the landscape in a hush. Imagine the first delicate snowflakes drifting down from a sky that seems to hold its breath. Each flake, a tiny, intricate crystal, unique in its silent descent, landing on a bare branch or a frosted window pane. They don't fall with a rush or a clamor, they simply arrive, as if materializing from the very air, settling with an almost imperceptible sigh. This is the sort of quiet we seek, a quiet that isn't empty, but full of the gentle presence of things at rest. Feel the air against your skin. Perhaps it carries the memory of warmth from the day, or perhaps it already holds the crisp promise of night. When you breathe out, can you see the faint, ethereal mist of your own breath lingering for a moment before dissolving? That visible breath is a small, tender miracle, a fleeting cloud of warmth and moisture encountering the coolness of the world. It's a tiny, personal whisper of energy, a gentle reminder that even within us, there is a constant, subtle dance of heat and movement. The world slows in winter. The trees stand stark and patient, their branches reaching like the dreaming arms of ancient beings. The busy scurrying of summer seems a distant memory, replaced by a profound stillness. Rivers that once rushed and tumbled now flow with a more deliberate grace, or perhaps even hold their breath beneath a thin, glassy skin of ice. The sounds become muted, absorbed by the blanket of snow or the density of the cold air. It's as if the earth itself has decided to take a deep, slow breath, holding it, savoring the tranquility before the burst of spring's awakening. This is a tranquility that does not demand attention, but invites it, gently, persistently. In this quiet winter scene, everything, even the seemingly inanimate, is still in its own way, vibrant with a hidden energy. The very air, though still, is a vast, invisible ocean of tiny, dancing particles. These particles are not truly still, not ever. Even in the deepest cold we experience in our everyday lives, they are engaged in a perpetual, intricate ballet, bumping into one another, vibrating, spinning, a cosmic hum that is usually beyond our perception, but is the very essence of what we feel as warmth. Imagine these particles, atoms, and molecules as countless, tireless little dancers. In the warmth of a summer's day, they are a bustling carnival, a vibrant, joyous crowd swirling and twirling with boundless enthusiasm. They collide with exuberance, their movements quick and wide-ranging. This energetic commotion is what we sense as heat. When the sun warms your skin, it is these microscopic dancers, imbued with extra vigor, tapping against the delicate sensors in your skin, sending messages of warmth to your mind. But as the world cools, as the winter air embraces everything, the music of this molecular dance begins to slow. The carnival atmosphere gradually recedes, replaced by a more measured, graceful waltz. The dancers still move. Yes, but their steps become shorter, their twirls less frantic, their collisions softer, less frequent. They are not stopping. Not yet. But they are conserving their energy, settling into a rhythm that is more contemplative, more serene. This slowing down is what we perceive as the fading of heat, the creeping embrace of cold. Think of a grand ballroom filled with dancers. When the music is fast and vibrant, everyone is leaping, spinning, moving across the entire floor. This is high temperature, the energy is palpable, infectious, but then imagine the music softening, becoming a slow, deliberate melody. The dancers don't stop. They simply shift their movements. Their steps become smaller, their turns tighter, their focus perhaps more inward. They are still moving, still expressing the music, but with a calmer, more introspective grace. This is the subtle magic of cooling, a transition from exuberance to a quiet, elegant motion. Even the light around us can be understood through this lens of tiny, energetic dancers. Light itself is made of photons, particles that are always in motion, always traveling at an incredible speed. But the source of that light, whether it's the sun, a lamp, or even the glow of an ember, is born from the frantic dance of atoms. When atoms get excited, when their internal dancers are particularly vigorous, they release little packets of energy, the photons that carry light. As things cool, as the atomic dancers become less agitated, they release fewer of these packets, and the light dims, just as the glow of dying embers fades into the darkness of a hearth, leaving only a lingering warmth and the memory of its former brilliance. The very act of seeing is a testament to this constant, invisible ballet happening all around and within us. Consider a pot of water simmering gently on a stove. The water molecules at the bottom are being energized by the heat, moving more vigorously, rising, while cooler, slower molecules sink. This creates a gentle, light swirling current within the pot, a visible manifestation of heat energy at work. Now, imagine removing the pot from the heat. The swirling slows, the currents become less pronounced. The water still moves, but it settles, becomes calmer, quieter. This analogy, simple as it is, begins to touch upon the profound concept of temperature. Temperature, in its deepest scientific sense, is not just a feeling of hot or cold. It is a direct measure of the average kinetic energy, the energy of motion, of the particles within a substance. The hotter something is, the faster and more energetically its particles are moving. The colder it is, the slower and more sedate their movements become. It's a collective rhythm, a shared tempo for billions upon billions of tiny entities. And so, as we look out at our imagined winter landscape, at the quiet snow, the mist of breath, the still trees, we are looking at the outer manifestation of an internal slowing. The world isn't just feeling cold, its very building blocks, its fundamental constituents, are moving more slowly, more deliberately. Their vibrant, chaotic dance has softened into a gentle sway, a quieter hum. This slowing down is not a loss, but a transformation, a shift in the symphony of the universe from a vibrant crescendo to a peaceful, lingering chord. This concept of particles in motion, and the gradual reduction of that motion, is our gentle entryway into understanding a truly profound idea, absolute zero. It's a concept that pushes the boundaries of our everyday experience, taking us beyond the familiar chill of winter to a place where motion itself becomes a whisper, almost a dream. It asks us to imagine a world where the very idea of heat, of kinetic energy, has almost entirely subsided, leaving behind a stillness so deep, so profound, it redefines what we understand as existence. Imagine a great-grandfather clock, its pendulum swinging rhythmically, each tick and tock a testament to the passage of time, a steady, measured beat. This is like the particles at a comfortable room temperature, a consistent, predictable motion. Now, picture that clock running down. The pendulum's arc shortens. Its swings become weaker, slower. The ticks become fainter, more spaced out, until eventually, with a soft, almost inaudible sigh, it comes to a complete rest. That final, absolute rest of the pendulum, where no further energy can be extracted from its motion, is a gentle metaphor for the elusive concept we are about to explore. It's a state beyond what we can truly experience, a horizon of stillness that exists as a profound theoretical limit. The very air that surrounds us, even in the stillness of this moment, is teeming with billions upon billions of tiny molecules. Nitrogen, oxygen, argon. They are constantly colliding, bouncing off each other and off the surfaces around them. This relentless, invisible ballet is the reason air has pressure, the reason it can carry sound, the reason it feels different when it's warm or cold. In a warmer room, these molecules are like tiny, frantic ping pong balls, zipping back and forth, hitting surfaces with more force and more often. When you feel a draft, it's not just cold air, it's a current of these tiny dancers moving with less vigor, thus transferring less energy to your skin. As we turn our minds towards the idea of reducing this motion, of making these countless tiny dancers slow their steps, we are embarking on a journey towards a truly unique state of being. It is a state where the familiar rules of our macroscopic world begin to blur, giving way to the strange, beautiful logic of the quantum realm. It's a journey that doesn't demand a loud exclamation or a sudden realization, but rather a quiet contemplation, a slow unpeeling of layers to reveal the subtle, intricate beauty beneath. The aim is not to understand this concept with a sharp, analytical mind, but to allow its gentle strangeness to wash over you, like the slow, quiet tide pulling back from a sandy shore, revealing patterns that were hidden beneath the more vigorous waves. Consider the whisper of the wind outside your window, a sound that is both present and fleeting. This whisper is born from the collective motion of air molecules. When the wind is strong, the molecules are moving rapidly and coherently, creating a rushing sound. When it's just a whisper, their motion is gentler, more fragmented, less forceful. Now imagine a wind so soft, so subtle that it is almost imperceptible. This is the direction we are heading, towards a state where the collective whisper of molecular motion becomes so faint, so quiet, that it approaches an almost absolute silence. It's a state where the very idea of a breeze or a current loses its meaning, because the individual dancers have nearly ceased their boisterous twirls, choosing instead to simply hold their positions, perhaps trembling just a fraction, a silent testament to the lingering ghost of their former energy. This slowing, this quieting, is a fundamental process in the universe. From the cooling of a freshly brewed cup of tea to the vast, slow cooling of a dying star, the tendency for things to lose their heat, to transfer their energy to their surroundings, is ever present. It's a cosmic sigh, a gentle settling towards equilibrium. But our journey will take us beyond these familiar acts of cooling, into a realm where we explore the absolute limit of this process, a place where the universe itself, if it could, would take its deepest, most profound breath and hold it. And as we prepare to delve deeper into this realm of extreme cold, let your own breath become slow and steady. Let your thoughts drift like those first delicate snowflakes, finding their gentle landing place. Allow yourself to feel the subtle coolness around you, not as something harsh, but as a soft, comforting presence. For in this quiet descent, in this gentle slowing of the world, we begin to glimpse the profound and poetic truths hidden within the very fabric of existence. Truths that reveal themselves not in grand pronouncements, but in the tender silence that follows the dance of particles, the dance of energy, the dance of life itself, all moving towards a profound, beautiful rest as the gentle chill of our imagined winter deepens, and the world outside seems to hold its breath in a quiet, thoughtful pause. Let us now turn our gaze inward, beyond the visible, beyond what our fingertips can touch. Let us imagine the unseen dancers within everything around us, and indeed within ourselves. These are the atoms and molecules, the fundamental building blocks of all that exists. And they are never truly still. They are engaged in a perpetual, intricate, and often vibrant ballet, a dance that defines their very essence. Think of a grand ballroom, shimmering with light, not necessarily a place of human celebration, but an infinite space where countless, tiny beings move with tireless energy. Each atom, each molecule is a tiny dancer, and their collective motion is what we perceive as heat. When a warm blanket drapes over you, It's not just its fibers that bring comfort, it's the multitude of molecules within those fibers, vibrating and jostling with a certain vigor, gently transferring their kinetic energy to the molecules in your skin. This transfer, this subtle giving and receiving of energetic nudges, is the very feeling of warmth. In a hot summer's day, these molecular dancers are like a bustling, joyous crowd at a festival. They are leaping, spinning, twirling with boundless enthusiasm. Their collisions are frequent and energetic, like playful bumps in a lively dance. The air itself is a flurry of motion, with gas molecules zipping past each other at hundreds of miles per hour, constantly bumping into anything in their path. This vibrant, almost chaotic energy is what makes the air feel warm, what makes the sunlight feel intense as its energetic photons stir the dancers on your skin into an even greater frenzy. But as our journey into stillness progresses, as the temperature begins its gentle descent, the music in our imagined ballroom begins to change. The rhythm softens. The tempo slows. The energetic festival atmosphere gradually recedes, replaced by a more measured, graceful waltz. The dancers, though still in motion, find their steps becoming shorter, their twirls less frantic, their movements more contained. They are not stopping, not yet, but they are conserving their energy, settling into a rhythm that is more contemplative, more serene. This gradual deceleration is the essence of cooling, a profound shift from outward exuberance to a quiet, inward grace. Imagine a swirling galaxy of dust motes caught in a sunbeam. In warmer air, they dart and dash, seemingly without pattern, their individual paths unpredictable. Each tiny speck is a testament to the invisible forces at play, to the constant bombardment by air molecules. As the air cools, the dust motes don't disappear, but their erratic dance becomes less pronounced. They still drift, still move, but with a more languid, almost sleepy rhythm. This macroscopic observation mirrors the microscopic reality as temperature drops. The average kinetic energy of the particles decreases. They don't cease to move entirely, but their movements become less energetic, less forceful, less frequent in their collisions. Consider the surface of a tranquil lake on a still evening. The water appears motionless, a perfect mirror reflecting the twilight sky. Yet, beneath that placid surface, countless water molecules are still in constant motion, jostling, slipping past one another, forming and breaking fleeting bonds. They are not rushing. They are not turbulent. Their movement is a gentle, a continuous whisper, a slow, patient shifting that allows the lake to flow, to evaporate, to exist as a liquid. This quiet, persistent motion is why even cold water is still liquid, a testament to the inherent, tireless activity at the molecular level. Even when the overall energy is low, every object we touch, every substance we perceive, is composed of these microscopic dancers. A solid object, like a smooth river stone, might seem perfectly still and inert, yet its atoms are not truly frozen in place. Instead, they are like tiny bells, vibrating gently within their fixed positions in a crystal lattice, chiming an unheard song. The warmer the stone, the more vigorously these atomic bells vibrate, their chimes growing louder, their tremors more pronounced. As the stone cools, their vibrations dampen, becoming softer, more subtle, until they are mere whispers of motion, barely perceptible hums. This internal tremor, this constant, almost imperceptible trembling, is the solid's way of expressing its thermal energy. It is a dance of restraint, a graceful swaying within strict boundaries. When you hold something warm in your hand, like a mug of tea, you are experiencing the transfer of this internal dance. The more vigorously vibrating molecules of the mug's ceramic are bumping against the molecules of your skin, transferring some of their energetic wobbles. It's like a gentle, rhythmic handshake between microscopic entities, passing on a bit of their vitality. The warmth spreads, not by magic, but by this constant, generous exchange of kinetic energy. And as the tea cools, the handshakes become less frequent, less forceful, until the mug eventually reaches equilibrium with the surrounding air, its internal dancers settling into a shared, quieter tempo. This understanding of heat as motion and cold as reduced motion is a fundamental pillar of our scientific poetry. It transforms abstract numbers on a thermometer into a vivid picture of billions of tiny, tireless beings performing their ceaseless ballet. Temperature, then, is not merely a quantity, but a descriptor of the collective vitality of these dancers. High temperature means high vitality, energetic leaps and bounds. Low temperature means subdued vitality, gentle swaying and quiet shuffles. As we continue our imaginary descent into colder realms, we are essentially asking these dancers to slow down even further. We are turning down the music, inviting them to find an even deeper state of repose. It's a challenge to our intuition, because in our everyday lives, stillness often implies no motion. But at the atomic level, true, absolute stillness is an elusive, almost unreachable goal. It's a horizon we approach but may never fully touch, because the very rules of the universe, the very fabric of reality, seem to dictate that even in the deepest silence there must be some lingering whisper of movement. Consider the molecules of air in a perfectly still room. Even without a breeze, they are moving at incredible speeds, bumping into walls, furniture, and each other thousands of times per second. If you could see them, it would be a blinding blur of activity. This constant, invisible agitation is a source of pressure. It's why a balloon inflates, why air pushes against things. As we cool the air, these impacts become less frequent and less forceful. The pressure drops. The vibrant energy that once pushed outwards begins to recede, drawing inward, like a shy bloom folding its petals as the light fades. The beauty of this molecular dance lies in its inherent democracy. Every particle, regardless of its size or composition, participates in this thermal ballet. Whether it's a massive gold atom or a tiny hydrogen atom, they all respond to the collective energy of their surroundings. And they are always seeking balance. Just as a drop of ink disperses in water until it evenly colors the whole, so too does heat energy spread until it is evenly distributed among all the particles in a system. This constant striving for equilibrium is what drives all natural processes of heating and cooling. A gentle diffusion of vitality until every dancer shares the same quiet, steady rhythm. We often use the term frozen to describe something very cold, like ice. And while the water molecules in ice are indeed locked into a more rigid structure, they are not entirely motionless. They are still vibrating in place, shivering gently within their crystal lattice. The colder the ice, the less pronounced these shivers become. But they never truly cease. It's like a vast, silent chorus of tiny instruments, each playing its own note, but doing so with decreasing fervor as the temperature drops, until their sound is almost entirely absorbed by the profound quiet that surrounds them. The very act of freezing is not a cessation of all motion, but a transformation of the dance from a free-flowing waltz to a more stately, almost reverent, standing sway. This subtle, persistent motion, even in the coldest conditions, is a key insight into the nature of reality. It tells us that energy is a fundamental, almost sacred aspect of the universe. It is never truly destroyed, only transformed, redistributed, or expressed in different ways. Even as we guide our molecular dancers towards a state of profound stillness, we are not erasing them, or their inherent energy. We are simply inviting them to perform their most subtle, most introspective routine, a movement so delicate that it borders on the edge of nothingness, yet still retains the ghost of its vibrant past. And so, as you settle deeper into your own quiet space, imagine this ceaseless ballet unfolding around you, within you. Feel the gentle warmth of your own body, a testament to the ceaseless, life-giving dance of your own atoms and molecules. Recognize that even the coolest air, the most tranquil water, holds within it this hidden symphony of motion. It's a profound realization, a scientific poem whispered by the very fabric of existence that even in the quietest moments, beneath the most serene surfaces, the universe is alive with a subtle, beautiful, and utterly captivating dance of energy. It is a dance that is never truly over, merely changing its tempo, finding new, more gentle rhythms as it gracefully moves towards a stillness that promises rest, but never true cessation. As our imagined dancers of energy continue their slow, graceful waltz, their once vibrant leap softening into more contained, introspective movements, we approach a fascinating threshold. We are moving towards a concept that challenges our everyday understanding of stillness. A point where the music of molecular motion becomes so faint, it is almost indistinguishable from silence. This is the realm of absolute zero, a theoretical limit, a profound whisper at the very edge of possibility. Imagine a vast, ancient lake, its surface stretching out under an endless sky. For eons, countless raindrops have fallen upon its serene expanse, each a tiny gift from the heavens, each carrying a whisper of movement, a spark of energy. When the lake is warm, these raindrops create ripples that spread outwards, intertwining with the ripples from countless others. A dynamic tapestry of continuous motion. The surface is alive, constantly shifting, reflecting the vibrant dance happening both within its depths and above it. Now, picture this lake as the temperatures begin their deep, slow descent. The rain continues to fall, but the air grows colder, settling into a profound stillness. The drops, instead of creating energetic ripples, now land with an almost imperceptible plink. Their energy quickly absorbed by the chilling surface, the ripples they do create are smaller, more fleeting, barely disturbing the developing tranquility. This is a gentle metaphor for how the energy of individual particles diminishes as they are cooled, their once forceful impacts becoming softer, their effects less far-reaching. As the cold deepens, the lake itself begins to feel the profound influence of the cooling air. A delicate, transparent skin of ice starts to form along its edges, spreading inward with a slow, deliberate patience. This ice is not a sudden, violent transformation, but a gradual embrace of stillness, molecule by molecule. The water molecules that were once freely slipping past one another, performing their liquid ballet, now begin to align, to hold hands, forming a more rigid, ordered structure. They haven't stopped moving entirely. No, they are like dancers who have found their partners and are now swaying gently in place, holding perfectly still relative to one another, but still trembling with an internal, contained energy. This slow, patient formation of ice is a tangible, everyday example of energy being withdrawn from a system. The molecules lose enough kinetic energy that their attractive forces can lock them into a fixed pattern. The once fluid or flowing nature gives way to a crystalline, almost sculptural stillness. Yet, even in the solid ice, as we touched upon earlier, that the atoms are not truly motionless. They are like tiny, perfectly tuned tuning forks, vibrating ever so slightly within their crystalline lattice. The colder the ice, the less pronounced these vibrations become, their hum softening to an almost inaudible drone. This concept of reaching a point where all thermal motion ceases, or approaches cessation, is the essence of absolute zero. It is not just about things being cold, but about the absolute absence of the energy of motion that we perceive as heat. It's a theoretical temperature, about 273.15 degrees Celsius, or 459.67 degrees Fahrenheit. These numbers, though precise, are merely markers on a map leading to a state of profound scientific poetry. The true wonder lies not in the digits, but in the implications of such a state. Imagine a world where the frenetic dance of molecules has finally quieted. No more energetic collisions, no more vibrations, no more frantic zipping and zooming. The very idea of a wind or a current would lose its meaning because there would be no collective directional flow of energetic particles. It's a silence so deep, so absolute, that it redefines the very concept of motion. The particles would simply be there, in their lowest possible energy state, each one holding its breath, a still point in the vastness. However, here's where the scientific poetry takes a beautifully strange turn. Even at absolute zero, according to the laws of quantum mechanics, there is a lingering inherent wobble. This is known as zero-point energy. Think of it like this: even if our dancers in the ballroom have stopped their conscious movements, even if the music has completely faded, there's still a tiny, almost imperceptible tremor in the floor itself, an inherent, fundamental vibration that prevents true, absolute stillness. It's not a thermal motion that can be extracted or transferred as heat. Rather, it's an intrinsic, unavoidable quantum jitter, a final soft pulse of existence. This zero-point energy is a deeply strange but also kind of beautiful idea. It means that the universe, at its most fundamental level, never truly reaches a state of perfect, inert cessation. There is always a flicker of potential, a quiet hum of existence, even in the deepest theoretical cold. It's like the gentle, like almost imperceptible rise and fall of a sleeping chest, a sign of life, even in profound rest. It's the universe's quiet reassurance that, even at the edge of stillness, there is a fundamental vitality. To grasp the magnitude of reaching absolute zero, consider how challenging it is to achieve. Scientists, in their quiet, patient laboratories, work tirelessly to cool matter to temperatures incredibly close to absolute zero. They use sophisticated techniques, like laser cooling, where carefully tuned laser beams are used to gently nudge atoms, slowing their movement down, much like a shepherd gently guides a flock with subtle movements. Each nudge takes away a tiny bit of their kinetic energy, coaxing them towards this ultimate state of stillness. It's a delicate dance of precision, a testament to humanity's profound curiosity and its desire to understand the very limits of reality. The closer they get to absolute zero, the stranger matter behaves. It's like watching our ballroom dancers, now so slow, that their individual movements begin to blur into a single, unified sway. The laws of classical physics, which govern our everyday world of pushing and pulling, start to fade into the background, and the mysterious, probabilistic rules of quantum mechanics take center stage. Things that seem impossible in our warm, energetic world begin to manifest. This transition is not jarring or dramatic. It's a slow, almost imperceptible metamorphosis, like the gradual fading of colors at twilight, revealing a different, equally beautiful spectrum. Imagine a vast, empty cosmic canvas. In our everyday experience, this canvas is perpetually being brushed with the vibrant strokes of heat energy, each stroke representing the motion of countless particles. At absolute zero, it's as if all those brushes have been gently laid down. The canvas isn't entirely blank. It still holds the faint, inherent texture of its own being, the whisper of zero-point energy. It is a canvas of immense potential, capable of holding the stillness of profound rest, yet also retaining the subtle possibility of future motion, a gentle, waiting silence. The very idea of absolute zero invites us to reflect on the nature of energy itself. Is it something that can truly be used up, or is it merely transformed, hidden, or expressed in ways we don't immediately perceive? The existence of zero-point energy suggests that energy, in some fundamental form, is an intrinsic part of the universe, not something that can be entirely erased. It's like the deep, resonant hum of the earth itself, always present, even when we don't consciously hear it. As you lie here, listening, perhaps your own body temperature feels just right, a comfortable warmth that allows for peaceful rest. This warmth is a testament to the constant, gentle motion of the atoms and molecules within you, each performing its tireless dance to sustain life. Your breath flows in and out, a gentle rhythm that embodies a controlled exchange of energy. And in this gentle rhythm, there is a beautiful parallel to the concepts we are exploring. The slowing of breath, the quietening of the mind, are personal pathways to a kind of inner stillness, a mimicry of the cosmic journey towards absolute zero. This theoretical point of absolute zero is not a place of desolation or emptiness. Rather, it is a place of profound clarity, where the distractions of thermal motion are stripped away, revealing the underlying quantum reality of matter. It's like looking at a perfectly still pond on a clear night, its surface undisturbed by ripples, allowing the reflection of the stars to be breathtakingly sharp and undistorted. In such a state, the fundamental nature of the particles, their wave-like properties, their intricate quantum entanglements, become vividly apparent. It is a canvas of pure potential, a realm where the strange and wonderful rules of the universe are laid bare in their most elegant, unadulterated form. So, as we contemplate this limit, this quietest of places, let your mind drift with the thought of ultimate stillness. Not a scary, empty stillness, but a peaceful, profound cessation of energetic clamor. Imagine the universe taking a deep, deep breath, holding it, and resting in its most fundamental state. It's a concept that invites tranquility, a reminder that even the most complex scientific ideas can be approached with a gentle, poetic heart, revealing their inherent beauty and their quiet, powerful truths. This quietness, this approach to ultimate stillness, is not an ending, but a revelation, a gentle unveiling of the universe's deepest, most serene secrets. As we continue our gentle descent into the realm of profound cold, where the vibrant dance of molecules softens to an almost imperceptible whisper, we encounter a layer of existence that defies our everyday intuitions. We've explored the idea that even at the theoretical limit of absolute zero, a faint, inherent tremor persists. The zero-point energy, this subtle, unwavering hum, is not a flaw in our understanding, but a beautiful, deeply strange truth born from the very fabric of the universe, the world of quantum physics. Imagine a vast, silent lake, perfectly still, reflecting the deepest night sky. On its surface, if you look closely, you might notice the most delicate of ripples, not caused by a breeze or a falling raindrop, but by an unseen, continuous pulse from the very depths of the water itself. These are not the energetic waves of a stormy sea, but rather the gentlest of undulations, almost breathing in their subtle rise and fall. This is a quiet way to envision zero-point energy and intrinsic, unavoidable quantum jitter, a fundamental tremor that is part of the lake's very nature, even in its most profound stillness. This idea might sound a little strange, perhaps even paradoxical, especially when we are trying to imagine a state of ultimate stillness. How can something be still and yet still tremble? This is where the wisdom of quantum mechanics comes in, a wisdom that often speaks in whispers and probabilities rather than loud, certain pronouncements. In our macroscopic world, a ball at rest is truly at rest, but in the tiny, subatomic realm, where the rules are subtly different, particles are never truly absolutely frozen in place. They exist as much in a cloud of possibilities as they do as distinct points. Think of it like a sleeping child. Even in the deepest slumber, there is a gentle, rhythmic rise and fall of the chest, a soft flutter of eyelids, an occasional, almost imperceptible shift in position. This is not a conscious movement, but an inherent sign of life, a fundamental process that keeps the body alive even in repose. Zero-point energy is much like this, a fundamental, unavoidable, inherent motion that cannot be completely stilled, even at the lowest possible energy state. It's the universe's quiet assurance that life, in some form, is always whispering. This beautiful strangeness is encapsulated in the Heisenberg uncertainty principle. Don't let the grand name sound intimidating. It's quite poetic when you consider its implications. It softly suggests that you can't know everything about a tiny particle with absolute, pinpoint precision at the same time. If you know exactly where a particle is, you can't know its exact momentum, its movement. And if you know its exact momentum, you can't know its exact position. It's like trying to perfectly capture a bird mid-flight with both its exact location and its exact velocity. If you focus too sharply on where it is, its trajectory becomes uncertain. If you focus on its trajectory, its precise spot in the sky blurs. What does this mean for our journey towards absolute zero? It means that if we were to force a particle to be perfectly still, meaning it has zero momentum, then its position would become completely uncertain, spread out infinitely. And conversely, if we try to pin it down to an exact spot, it would have to possess some inherent, irreducible motion. This fundamental fuzziness, this inherent dance of uncertainty, means that particles can never truly have zero kinetic energy and be perfectly, absolutely frozen in a single spot. There will always be a residual jiggle, a background hum, a quantum wobble. It's not an imperfection, but a deeply fundamental truth about how the universe is woven. Imagine a vast still pond covered in a layer of thin, shimmering ice. The ice appears perfectly smooth, motionless. But if you were to look extremely closely, perhaps with the eyes of a tiny insect, you might perceive the almost invisible ripples beneath the surface, a constant subtle tremor that prevents the water from ever being truly, absolutely solid and inert. These are not ripples caused by wind or external forces, but by the intrinsic internal life of the pond itself. This is the quantum world at play, a hidden ballet of probabilities. This quantum ballet is what gives rise to many of the truly bizarre and beautiful phenomena that occur near absolute zero. When atoms are cooled to temperatures incredibly close to this theoretical limit, their wave-like nature becomes much more pronounced. Instead of acting like distinct, tiny billiard balls, they begin to behave more like overlapping ripples in a pond, their individual identities blurring into a collective, unified behavior. This is a profound shift, a quiet metamorphosis where the familiar rules of matter seem to melt away, revealing a deeper, more ephemeral reality. Consider a great cloud of microscopic fireflies, each blinking with its own light, each following its own path. This is how we might imagine a gas at warmer temperatures, a multitude of individual entities, each with its own energy and trajectory. As we cool this cloud, the fireflies slow their movements, and their blinks become less frequent. But at temperatures very close to absolute zero, something extraordinary can happen. Instead of remaining as distinct fireflies, they begin to coalesce, to merge their lights, their individual blinks synchronizing until they become one vast, unified glow, a single, coherent wave of light. This is an analogy for the formation of a Bose-Einstein condensate, which we will explore in our next chapter, a state where individual atoms lose their separate identities and begin to behave as a single, macroscopic quantum entity. This transition from individual and distinct particles to a unified, wave-like entity is not abrupt or dramatic. It's a slow, graceful unfolding, like the gradual blending of colors in a twilight sky. As the temperature drops, the wavelength associated with each particle, a concept tied to its quantum nature, becomes longer, so long that it begins to overlap with the wavelengths of its neighboring particles. When these quantum waves overlap perfectly, they can synchronize, creating a single enormous wave that encompasses many atoms. It's a beautiful symphony of coherence, a quiet testament to the underlying unity of matter. Even the very idea of empty space is not truly empty in the quantum realm. It is not a void, but a bubbling, frothing sea of virtual particles, constantly popping into existence and disappearing again in a fleeting dance. These are not real particles in the sense that they can be directly observed or easily interacted with, but their fleeting presence, their quantum flicker, is a fundamental aspect of the universe. This concept, though seemingly unrelated to cold, reinforces the idea that true absolute nothingness, a complete absence of all energy and activity, is a profound challenge to the quantum understanding of reality. There is always a faint hum, a potential for activity, even in the deepest theoretical silence. So, when we talk about reaching absolute zero, we are not imagining a realm of inert, frozen silence. Instead, we are picturing a state where thermal motion, the kind of kinetic energy that gives rise to heat and makes things bustle and vibrate, has been brought to its absolute minimum. But even there, at the very bottom of the energy well, the universe retains a subtle inherent pulse, a quantum whisper that cannot be stilled. It's a reminder that beneath the apparent stillness of deep cold, there lies a vibrant, if extremely subtle, quantum landscape, full of hidden possibilities and strange, beautiful truths. As you rest, let your mind gently consider these profound ideas. The universe, in its deepest reality, is far more subtle and wondrous than our everyday senses might suggest. Even in the deepest imagined cold, there is a fundamental tremor, a gentle hum, a quiet pulse. It is a reminder that motion, in some irreducible form, is woven into the very fabric of existence. A silent promise that even in the most profound rest, there is an enduring vitality, a soft, continuous breath from the heart of the cosmos. This quiet, persistent energy, even at the edge of the absolute, is a comforting thought, a gentle lullaby from the universe itself. Having gently considered the persistent tremor of zero-point energy and the subtle, wave-like nature of particles in the quantum realm, we are now ready to drift deeper into the truly extraordinary. As temperatures approach the brink of absolute zero, matter can reveal a state so unusual, so utterly unified. It seems like a dream made real. This is the Bose-Einstein condensate, often called the fifth state of matter, a profound testament to the universe's capacity for coherence and stillness. Imagine a vast field of fireflies on a summer night, each tiny light blinking independently, following its own whimsical path. Their individual flickers create a dynamic, disorganized display. This is akin to how atoms behave at warmer temperatures, a multitude of distinct entities, each with its own energy and trajectory, buzzing around in a lively, if chaotic, dance. Their individuality is paramount. Each firefly is a separate, unique spark of life. Now, picture this field as the night deepens, and a mystical, unseen force begins to work its magic. The fireflies don't simply slow their individual blinks. Something far more profound occurs. Their separate lights begin to coalesce, to merge, to synchronize. One by one, their individual flickers align. Their movements become perfectly coordinated until they are no longer distinct points of light, but a single, vast, unified glow, pulsating with a harmonious, collective rhythm. The boundaries between them seem to dissolve, and they behave as one immense, luminous being. This is the essence of a Bose-Einstein condensate individual atoms losing their separate identities and merging into a single, macroscopic quantum entity. This phenomenon doesn't happen with all types of atoms, only with those known as bosons. Think of bosons as atoms that are inherently gregarious, possessing an almost poetic inclination to share their quantum space. Unlike fermions, which are more like shy, solitary dancers who prefer their own unique spot on the floor, bosons are eager to combine to overlay their wave-like properties to exist in the very same quantum state. It is this unique social characteristic of bosons that makes the condensate possible. To create this ethereal state, scientists must coax atoms to temperatures incredibly, almost unimaginably close to absolute zero. We're talking about fractions of a degree above that theoretical limit, so cold that almost all thermal motion has been painstakingly drained away. At these ultra-cold temperatures, the atom's quantum wavelengths, those gentle, invisible ripples we spoke of, become so large that they begin to overlap. And when these ripples overlap perfectly, they don't just interfere, they harmonize, joining together to form one giant, overarching wave. This enormous unified wave is the Bose-Einstein condensate. It's like taking countless individual musical notes, each played by a separate instrument, and then gently slowing their rhythm, stretching their tones until they all blend into one single, perfectly sustained chord, so deep and resonant that it seems to vibrate from the very air itself. The individual instruments are still there, but their separate voices have merged into a unified, harmonious whole. This state is often referred to as a superatom, not because it's a giant atom in the traditional sense, but because millions or even billions of atoms are acting as one, obeying the same quantum rules simultaneously. In this state of coherence, matter behaves in truly bizarre and beautiful ways. For instance, a Bose-Einstein condensate exhibits superfluidity, meaning it can flow without any viscosity, without any friction whatsoever. Imagine a dreamlike river, so smooth and effortless in its flow that it meets no resistance from its banks or from within itself. It could swirl in a loop forever, an eternal current, never losing energy to friction. This is because within the condensate, the atoms are no longer bumping into each other as distinct particles. They are moving as a single unified wave, encountering no internal opposition. Furthermore, a condensate can behave as a superconductor under certain conditions, allowing electricity to flow with zero resistance. Think of electricity not as tiny balls rushing through a wire, but as a gentle, continuous current of energy flowing through a perfect, unimpeded path. In our everyday world, electricity always encounters some resistance, like a river pushing against stones and mud. But in a superconductor, or within a Bose-Einstein condensate that exhibits this property, the pathway is like a perfectly polished slide, allowing the flow of energy to proceed effortlessly, without any loss or struggle. The discovery and creation of Bose-Einstein condensates were triumphs of patient, meticulous science, a testament to humanity's ability to gently coax nature into revealing its deepest, most counterintuitive secrets. It's like a sculptor, with infinite patience, slowly, carefully revealing the delicate form hidden within a block of stone, until the final creation seems to breathe with an ethereal life of its own. These condensates exist for only fleeting moments in carefully controlled laboratory environments. Tiny, ephemeral clouds of unified matter. Yet their existence confirms the profound strangeness and beauty of the quantum world at its coldest, most coherent extreme. This coherent state, where individual identities blur into a unified whole, has a deep, almost meditative resonance. It speaks to the potential for harmony and unity that lies beneath the apparent chaos of individual existence. When everything slows down, when the noise and frantic energy subside, a deeper but more profound connection can emerge. It's a reminder that sometimes the most powerful and beautiful states arise from a process of letting go, of allowing individual components to surrender their separate wills to a greater, collective harmony. Imagine the universe not as a collection of separate stars and galaxies, but as a vast, continuous tapestry, where each thread, though distinct, is ultimately woven into the larger whole. At warmer temperatures, each thread might stand out vividly, its individual color and texture pronounced, but at the profound chill of a Bose-Einstein condensate, it's as if the threads begin to melt into one another, their distinctness fading, their colors blending into a single, seamless hue. This is a universe revealing its deepest, most unified self, a quiet, flowing current of interconnectedness. As you drift towards rest, consider the quiet power of this unity. Your own body, a magnificent collection of countless atoms and molecules, is constantly seeking a state of balance and harmony. When you breathe deeply, when your mind stills, you are, in a very small, personal way, mirroring the universe's journey towards coherence. You are allowing the individual busy thoughts and sensations to subside, inviting a unified sense of peace to gently settle over you. The Bose-Einstein condensate is a scientific marvel, but it is also a poetic revelation. It tells us that even in the deepest cold, at the edge of stillness, there is not an absence, but a profound presence of interconnectedness. It is a state where the individual whispers of motion merge into a single, resonant hum, a gentle, powerful testament to the underlying harmony of the cosmos. Let this image of ultimate unity and effortless flow guide your thoughts. A soft lullaby from the heart of the universe, inviting you to release all individual tensions and simply drift into a state of profound, coherent rest. Having explored the ethereal unity of the Bose-Einstein condensate, where atoms merge into a single collective wave, we now turn to another remarkable phenomenon that emerges from the profound chill near absolute zero superfluidity. This is a state of matter so unusual, so frictionless, it challenges our very understanding of how liquids move. Imagine a river, but not one we know from our everyday world, with its currents and eddies, its resistance against the banks, and the subtle friction between its own flowing layers. Instead, picture a dreamlike river of liquid helium, so profoundly cold that it defies all conventional expectations. This river flows without any viscosity, meaning it experiences absolutely no internal friction. It doesn't drag against itself, nor does it resist flow around obstacles. It simply moves, effortlessly, perpetually. If you were to set this river swirling in a circular channel, it would continue to swirl forever, an eternal current, never losing energy to the gentle pull of friction that eventually brings all ordinary motion to a halt. This ability to flow without friction, to move in a continuous, unimpeded manner, is the hallmark of a superfluid. It's like the universe whispering a secret about perfect, unhindered motion. In our everyday experience, every liquid, no matter how thin it seems, has some viscosity. Honey is very viscous, molasses even more so. But even water, with its fluid grace, has a tiny bit of internal stickiness that slows it down over time. But a superfluid, in its remarkable coldness, sheds this stickiness entirely. It flows as if it were a ghostly current, passing through the smallest pores and climbing walls of its container, seemingly defying the very pull of gravity. This strange behavior isn't about the individual particles suddenly losing their desire to bump into things. Instead, it's a macroscopic manifestation of quantum mechanics at play. At these ultra-cold temperatures, the helium atom, specifically the isotope helium-4, which is a boson, like the atoms in our Bose-Einstein condensate, begin to enter the same quantum ground state. They behave like our unified fireflies, no longer distinct entities jostling against each other, but a single, coherent wave. When they move as one, there are no individual collisions that would generate friction. It's a collective, perfectly synchronized flow. Think of a vast, perfectly choreographed ballet. Each dancer moves with exquisite precision, their steps perfectly timed, their gestures flowing seamlessly into one another. There are no missteps, no bumping of elbows, no wasted movements. The entire ensemble moves as a single, living sculpture. This is how the atoms in a superfluid operate, not as individuals, but as a perfectly synchronized collective. Their motion so harmonious that it creates no internal resistance. This is why a superfluid can even creep up the sides of a beaker and over the top, forming a thin, climbing film. It's not climbing in the traditional sense, rather, the entire fluid is seeking its lowest energy state. And because there's no friction to stop it, it simply flows until it achieves a uniform thickness everywhere, like a perfectly even dew spreading across a leaf. The concept of superfluidity gently challenges our intuitive understanding of the word still. Even though the overall temperature is incredibly low and thermal motion is almost entirely suppressed, the fluid itself is in a state of dynamic, coherent motion. It's not static, it's flowing, but doing so with such exquisite, unhindered grace that it resembles a profound stillness. It's like a deep, silent river that seems motionless from above, yet carries an immense, unseen current beneath its placid surface. The stillness here refers not to a lack of movement, but to an absence of the chaotic, energy-dissipating movement we associate with heat. Superfluidity is a direct cousin to superconductivity, which also emerges in some materials at extremely low temperatures. In a superconductor, electrons can flow through a material with zero electrical resistance, meaning electricity can travel indefinitely without losing any energy as heat. Just as our superfluid river flows without friction, a superconducting current flows without electrical stickiness. Both phenomena are profound manifestations of the quantum world at its most ordered and unified, revealing a universe capable of extraordinary efficiency when thermal agitation is hushed. These superstates are a testament to how profoundly different matter can behave when we gently coax it to its coldest possible configurations. They are not merely scientific curiosities. They are windows into the fundamental nature of reality, showing us what happens when the chaotic noise of thermal energy is quieted, allowing the deeper, more elegant patterns of quantum mechanics to emerge. It's like listening to a subtle melody that is usually drowned out by the clamor of a bustling city. Only when the city sleeps can the melody be truly heard, clear and resonant. The study of superfluids and superconductors has opened up entirely new fields of research, leading to potential breakthroughs in energy transmission, quantum computing, and even new ways to measure fundamental forces. But beyond the practical applications, there's a deep, quiet beauty in these states. They whisper to us of perfect flow, of effortless motion, of a universe where energy, if allowed, can express itself in its purest, most unhindered form. Imagine the breath of a sleeping being. It's a rhythmic, continuous flow, effortlessly drawn in and released. There is no struggle, no resistance, just a perfect, gentle cycle that sustains life. This is the essence of superfluidity, a state of perfect, unhindered flow, a natural rhythm devoid of effort or loss. It's a reminder that within the deepest stillness, there can be a profound and continuous movement, a silent, graceful dance that perpetuates itself without end. As you settle deeper into your own quiet space, allow the image of this frictionless flow to permeate your thoughts. Imagine your mind, your breath, your very being moving with such effortless ease. Release any resistance, any tension, any internal friction that might hold you. Just as the superfluid finds its path with perfect grace, allow yourself to drift into a state of profound relaxation, a state where thoughts flow without struggle, where your body feels light and unburdened, moving towards a truly restful, undisturbed stillness. This isn't an ending to motion, but a transformation into its most peaceful, efficient, and ultimately serene form. As we continue our gentle journey into the realms of extreme cold, having witnessed the extraordinary coherence of Bose-Einstein condensates and the effortless flow of superfluids, let us now expand our gaze outward, far beyond the confines of terrestrial laboratories, to the vast cold canvas of the universe itself. For in the deepest reaches of space that we find a cold that dwarfs any winter's chill, a cold that holds profound secrets about the very beginning and potential end of everything. Imagine floating in the absolute quiet of deep space, far from any star or galaxy. Here, the temperature hovers at an astonishingly low value just a few degrees above absolute zero. This isn't the cold you feel on a frosty morning. This is the cosmic background radiation, the lingering echo of the universe's fiery birth. It's a gentle, uniform chill that pervades all of space, a faint microwave glow that bathes everything in its almost imperceptible warmth. It is the universe's oldest and most profound whisper, a relic from a time when it was still a tiny, impossibly hot infant. Think of it like the fading embers of a colossal fire that ignited billions of years ago. Though the roaring flames of creation have long since subsided, and the universe has expanded and cooled immeasurably, there's still a residual warmth, a faint, universal glow that remains. This subtle warmth, just a few degrees, Kelvin about 270 degrees Celsius or 455 degrees Fahrenheit is the coldest natural temperature we know, a testament to the grand cooling process that has unfolded over eons. It's a silent, constant reminder of the universe's immense journey from intense heat to a state of profound, widespread chill. In this vast, frigid expanse, the concept of empty space takes on a new meaning. It is not truly empty, but permeated by these ancient, stretched-out light waves, the photons of the cosmic microwave background. They are so spread out, so low in energy, that they contribute only a whisper of warmth. Their once vibrant, energetic dance from the early universe has slowed to a languid, almost imperceptible sway. Much like our molecular dancers near absolute zero, they tell a story of immense expansion and cooling, a cosmic breath exhaled over billions of years. Yet, within this overwhelming cosmic cold, there are islands of intense fiery warmth, the stars. Imagine them as cosmic hearths, burning brightly against the backdrop of an almost absolute chill. Our own sun is one such hearth, a colossal furnace where atoms are squeezed and fused together, releasing incredible amounts of energy. The surface of the sun burns at millions of degrees, its core even hotter, a place where matter exists in a state of unimaginable energy and constant, furious motion. These stars are the antithesis of absolute zero, representing the pinnacle of heat and energetic activity. They are the cosmic alchemists, forging heavier elements from lighter ones. And in doing so, they push back against the universal tendency towards cold and stillness. Their light and heat stream outwards, creating fleeting pockets of warmth in the vast, cold ocean of space. Planets like our Earth, nestled just the right distance from a star, can bask in this warmth, allowing for the intricate, life-giving dance of complex molecules to unfold. This contrast between the deep, pervasive cold of the cosmos and the intense, localized heat of stars is a beautiful example of cosmic balance. It's like the interplay between the stillness of a winter night and the comforting glow of a distant fireplace. One defines the other, making each more profound. Without the vast, silent cold, the warmth of the stars wouldn't feel quite so precious, quite so vital. The universe, in its grand design, allows for both the ultimate stillness and the most vibrant energy to coexist. In a delicate, enduring cosmic ballet, consider the life cycle of a star, a cosmic story of energy and its gradual dissipation. A star begins its life by gathering vast clouds of cold gas and dust, drawn together by gravity. As this material collapses, it heats up, eventually igniting nuclear fusion, the engine of a star. For billions of years, it radiates energy, a glorious output of heat and light. But even stars are not eternal. Eventually, they run out of fuel, and their fiery dance begins to slow. Larger stars explode in a magnificent burst, scattering their elements into the coldness of space, while smaller stars, like our sun, gently cool and fade, becoming dim. Cold embers over unimaginably long timescales. This gentle cooling of a dying star is another grand-scale example of energy diminishing, of particles settling into a quieter, less energetic state. It's a vast cosmic sigh as the stellar furnace finally begins to dim, its once frenzied atomic dance slowing to a quiet hum, its brilliant light fading into the pervasive cold of the cosmos. This process doesn't happen quickly, but over billions and trillions of years, a profound, slow waltz towards a quieter existence. The journey from the intense heat of the Big Bang to the gentle chill of the cosmic microwave background is the universe's own story of cooling and expansion. It's like a grand, universal breath, exhaling and expanding outwards, gradually lowering its temperature and stretching out the energetic ripples of its birth. This cooling has allowed for structure to form, for gravity to pull matter together into galaxies and stars, and for the conditions to emerge that eventually led to life. The cold, then, is not just an absence, but a catalyst for complexity. a vast canvas upon which the vibrant art of the universe is painted. And so, as you lie in your quiet space, imagine this vast cosmic balance. Feel the subtle warmth of your own body, a tiny pocket of energy sustained by the light of a distant star, and in the darkness around you, imagine the pervasive, ancient chill of the universe, a silent, almost absolute cold that holds the memory of creation. It's a comforting thought, this cosmic interplay, a reminder that even in the vastness and the deep chill of space, there is a fundamental rhythm of existence, a gentle ebb and flow of warmth and cold, energy and stillness, constantly shaping the grand, unfolding story of everything. Let this sense of cosmic balance bring a deep calm to your mind, a profound peace that stems from understanding your small, yet significant one place within this vast and wondrous tableau. As we have drifted through the vast, cold emptiness of space, sensing the ancient chill of the cosmic background radiation and the fiery hearts of distant stars, our journey now leads us to a concept that might, at first, sound unsettling. It is the idea of the heat death of the universe, a distant theoretical future where all energy has spread out so evenly that nothing new can ever happen. Yet, as the sleepy scientist, I invite you to consider this not as a terrifying end, but as a cosmic lullaby, a story of ultimate tranquility and profound, unshakable stillness. Imagine a vast, magnificent garden, vibrant with a kaleidoscope of colors, alive with the hum of bees and the song of birds. Each flower is a tiny burst of energy, each creature a delicate flame of life. Energy. In this garden, flows constantly sunlight warms the soil. Plants convert that energy into growth, and animals consume plants, creating a ceaseless cycle of transformation and renewal. This is our universe in its vibrant youth and middle age, a place of constant activity and fascinating disequilibrium. Now, picture this garden, not collapsing in a dramatic blaze, but slowly, gently, over an unimaginably vast stretch of time, fading into a state of uniform quiet. The sun, having expended its fiery dance, cools into a dim ember. The flowers, having bloomed and scattered their seeds, return to the earth. The very air, once buzzing with life, becomes still, its molecules moving with ever-decreasing enthusiasm. This isn't a violent ending, but a slow, graceful winding down, a patient settling into profound rest. The heat death of the universe is a concept from thermodynamics. The study of heat and energy, it suggests that all systems naturally tend towards a state of maximum entropy, which can be thought of as a measure of disorder, or, more poetically, the spreading out of energy until it is uniformly distributed. Think of it like a drop of ink dispersing into a glass of water. At first, the ink is concentrated, a distinct, vibrant swirl, but over time, it spreads out, diluting until the entire glass is a uniform. Pale wash. There's no longer any order to the ink's position. It's perfectly dispersed. The universe, in this grand theoretical sense, is doing the same thing with its energy. In this ultimate future, stars will have long since faded. Black holes will have evaporated, and all matter will be dispersed into a thin, uniform soup of particles, each moving with the minimum possible energy, effectively at a temperature infinitesimally close to absolute zero. There will be no more hot spots or cold spots, no more differences in energy to drive any processes, no more light, no more heat, no more change. It will be a universe in a state of perfect, undifferentiated equilibrium, a vast, silent, and incredibly cold ocean of absolute sameness. This idea might seem bleak. This thought of a universe where all activity has ceased. But remember, this is a cosmic fairy tale about an ending so distant, so far beyond our human timescale, that it's more of a philosophical contemplation than an imminent threat. It speaks to a profound, ultimate peace, a state where the frantic dance of creation and destruction has finally found its deepest rest. It's like the universe itself taking a final, deep breath and then settling into an eternal, dreamless sleep. Consider the quietude of a vast, empty library at the very end of time. All the stories have been told, all the knowledge absorbed, and the whispers of curiosity have faded. The air within is perfectly still, the dust motes settled, the very concept of a narrative having reached its ultimate conclusion. This quietude, this absence of potential for new stories, is a gentle echo of the heat death. It's not a sad emptiness, but a profound completion, a state of perfect contentment where nothing more needs to be added or subtracted. Even events that seem incredibly violent, like the Big Bang, the universe's explosive birth, contribute to this eventual quietude. While it began with unimaginable energy, that energy has been expanding and spreading outwards ever since, cooling the universe as it goes. It was a rapid, intense burst. Yes, but what followed was a long, deep silence as the world changed, expanding its fabric, allowing space to stretch and cool. Think of it not as a bang, but as a single brilliant flash of light in the deepest darkness, followed by an endless, patient night where the light ever so slowly dims and diffuses, spreading its warmth thinner and thinner until it is almost entirely gone. The heat death scenario underscores the second law of thermodynamics, which, in its simplest form, states that the total entropy disorder or energy dispersal of an isolated system can only increase over time, or remain constant. It never decreases. This universal tendency is why a cup of hot coffee cools down, why a pristine room eventually gets messy, and why the universe itself, on its grandest scale, is gently tending towards this ultimate state of uniform energy distribution. But here's a comforting thought even in this theoretical future. There's still the lingering concept of our zero-point energy, that inherent quantum tremor. So it's not truly an absolute nothingness, but rather a state where all extractable, useful energy has been dissipated, leaving behind only the most fundamental, irreducible quantum hum. It's like a vast cosmic battery that is completely run down, yet still holds a faint internal hum from its very construction, a quiet memory of its potential. This cosmic lullaby offers a unique perspective on our own existence. We live in a universe brimming with energy, where differences in temperature and pressure drive all the dynamic processes that make life possible. Our very existence is a testament to the fact that the universe has not yet reached this ultimate equilibrium. We are part of the vibrant, ever-changing middle chapters of this grand story, a story of stars burning, planets forming, and life blossoming in defiance of the long, slow march toward stillness. So, as you listen to these thoughts, let any worries about this distant cosmic future simply drift away, like wisps of mist carried on a gentle breeze. This is a story for the very, very end, a theoretical destination far beyond our most distant imaginings. Instead, focus on the present quiet, the warmth of your own breath, the subtle peace that envelops you. The heat death is a concept that, paradoxically, can bring a profound sense of calm. It speaks of an ultimate rest, a final, complete relaxation of everything, a deep and unending quiet where the universe has, at last, found its deepest slumber. After contemplating the vast, distant quietude of the universe's ultimate repose, let us now gently spiral back towards what is immediate, tangible, and wonderfully alive. We have journeyed into the realms of profound cold and ultimate stillness, but it is crucial to remember that our universe, in its vibrant present, is far from that theoretical endpoint. It is, in fact, brimming with warmth, energy, and continuous motion, a testament to life's persistent dance. Imagine a tiny seedling pushing its way through the cool earth, reaching towards the light. This delicate act is a profound expression of warmth and energy. The sun, our familiar cosmic hearth, pours forth light and heat, bathing our planet in a life-giving embrace. This light is a continuous stream of energetic particles, each one a tiny messenger carrying warmth from millions of miles away. It persuades the molecules in the soil to vibrate with more enthusiasm, It coaxes the water within the plant to rise, and it ignites the complex chemical dances that allow life to flourish. The very act of breathing, something so fundamental and automatic, is a constant exchange of warmth and energy. With each inhale, a cool air enters your body, warming as it interacts with the inner landscape of your lungs. With each exhale, warm, moist air leaves, carrying away a small portion of your internal heat, gently contributing to the temperature of the room around you. This rhythmic ebb and flow is a continuous, quiet symphony of thermal dynamics, a gentle reminder that your very existence is a testament to the ceaseless, life-sustaining movement within. Consider the rhythm of your own heart, a tireless drum beating a steady tempo within your chest. Each beat is a small burst of mechanical energy, circulating the warm, life-giving blood throughout your body. Your internal temperature, a perfectly balanced warmth, is maintained by this constant, intricate dance of cellular processes, chemical reactions, and the ceaseless motion of billions of molecules. This innate warmth is a precious gift, a fragile bubble of vitality nurtured by the sun's distant embrace and the intricate machinery of your own being. Even when you are resting deeply, perhaps feeling the gentle coolness of the night air on your skin, your body is still a furnace of gentle activity. Muscles subtly adjust, cells repair and renew, and your brain hums with the quiet energy of dreams. This internal warmth is what allows for consciousness, for sensation, for the very experience of being. It is the antithesis of absolute zero, a vibrant, living testament to the power of energy to organize and sustain complexity. We live in a universe where the conditions for warmth are abundant. From the glowing embers of a campfire on a cool evening to the geothermal heat bubbling up from within the Earth's crust, energy is constantly transforming and expressing itself. The very ground beneath us, seemingly solid and still, holds a deep, inherent warmth from the planet's molten core, a slow, patient heat that radiates outwards, shaping landscapes and sustaining subterranean life. This warmth is a profound comfort, a reminder that even in the vastness of space, our home is a warm, nurturing haven. Think of a loaf of bread baking in an oven, filling the air with its comforting aroma. The raw ingredients, cold and distinct, are transformed by the gentle, pervasive heat. Molecules rearrange, textures soften, and new flavors emerge. This process, a simple act of culinary alchemy, is a beautiful analogy for the creative power of warmth and energy. It takes disparate elements and, through the application of just the right amount of heat, brings them together to create something new, harmonious, and utterly delightful. The warmth we experience is not a static state, but a dynamic balance. It is a constant interplay between the energy we receive from the outside, like the sun's gentle touch, and the energy generated from within, like the metabolic hum of our own cells. This balance allows for the delicate dance of chemical bonds to form and break, for complex structures to arise from simpler ones, and for the intricate, beautiful tapestry of life to continuously weave itself. It's a perpetual giving and receiving, a quiet symphony of energy and motion. Even the Earth's great oceans, vast reservoirs of water that moderate our planet's temperature, are in a constant state of gentle, thermal motion. Warm currents flow from the equator towards the poles, carrying heat and influencing climates, while cold currents from the depths rise to the surface. This immense, slow circulation is driven by differences in temperature and salinity, a planetary-scale example of heat energy seeking equilibrium, yet never quite achieving it, ensuring a continuous, life-sustaining flow. So, while the concept of absolute zero offers a poetic glimpse into ultimate stillness, it is the promise of warmth that truly defines our lived experience. It is the warmth of sunlight on our face, the comforting embrace of a loved one, the internal glow that sustains our dreams and allows us to awaken each morning with renewed vitality. This warmth is not merely a sensation, it is the very essence of life, a constant gentle reminder that the universe in its present form is a place of profound activity, continuous creation, and boundless energy. As you drift now, enveloped in your own personal warmth, remember that this internal glow is a reflection of the universe's ongoing story. It is a story of continuous motion, of vibrant energy, and of the persistent, undeniable power of life to blossom even amidst the vastness of cosmic cold. Allow yourself to be warmed by this knowledge, to feel the gentle hum of existence within you, and to surrender fully to the comforting embrace of the present moment. A moment rich with the enduring promise of life's warmth. And so, our long, gentle journey through the curious physics of absolute zero draws to a close. We have wandered through the familiar chill of winter, felt the intricate dance of invisible particles, glimpsed the profound stillness of theoretical limits, and even touched upon the bizarre unity of matter at its coldest. Now, as the final notes of our cosmic lullaby begin to fade, let us bring these vast ideas back to the most personal space of all the quiet chamber of your own mind, the warm embrace of your own body, and the threshold of sleep. Think of your body, as you lie here, as a magnificent, self-contained universe. Within you, countless atoms and molecules. Those tireless dancers we spoke of continue their ceaseless, life-giving ballet. Even in this moment of stillness, they vibrate, they hum, they exchange energy, maintaining the delicate balance that is your very being. Your internal temperature, that perfect, comforting warmth, is a testament to this continuous, intricate motion, a vibrant defiance of the external chill. It is a warm, safe harbor for consciousness, a gentle flame against the vast, cold backdrop of the cosmos. As you prepare to surrender to sleep, notice how your own system begins its journey towards a profound state of rest. Your breath, which has been flowing in and out like a gentle tide, might deepen and slow. The thoughts that have been dancing in your mind, perhaps like scattered fireflies, begin to lose their individual brilliance, their urgency fading as they coalesce into a more general, softer awareness. This is your own personal descent towards a kind of inner absolute zero, not a physical cold, but a mental and emotional quietude. Sleep is not an absence, but a transformation of consciousness. It is a state where the active, analytical parts of your mind gently recede, allowing other, deeper currents to flow. Just as a superfluid moves without friction, sleep allows your mind to drift effortlessly, unburdened by the resistances of wakefulness. It's a time for your internal dancers, your neurons, your cells, to settle into a more harmonious rhythm, repairing, restoring, and renewing themselves in the silent, profound dark. Imagine your brain, during wakefulness, as a bustling marketplace, filled with the lively chatter of thoughts, the constant movement of sensations, and the bright lights of awareness. But as sleep gently descends, the market slowly closes, the chatter softens, the movements become slower and the lights dim, one by one. Eventually, the marketplace is still, not empty, but filled with a quiet, lingering potential, ready to awaken renewed in the morning. This deep rest allows for profound healing, for the integration of memories, and for the quiet blossoming of dreams. The zero-point energy we discussed, that irreducible quantum tremor even at ultimate cold, finds a beautiful parallel in sleep. Even in your deepest slumber, your body maintains a fundamental, irreducible level of activity. Your heart beats, your lungs breathe, your cells live. These are the whispers of life, the inherent, persistent hum of your existence, even when your conscious mind is far away, wandering through dreamscapes. This profound, underlying vitality is always present, a silent promise of awakening. Let go of any thoughts that cling, like stubborn ice crystals to a branch. Allow them to melt and diffuse, just as heat spreads evenly until all differences are gone. Let your muscles soften, releasing all the tension they have held throughout the day. Feel your body becoming heavier, sinking gently into the surface beneath you, as if finding its most natural, lowest energy state. This surrender to gravity, this embrace of stillness, is a profoundly comforting act. Think of the vast, cold stillness of the universe we explored, not as something desolate, but as a canvas of ultimate potential, a place where the fundamental truths of existence are revealed in their purest form. Your sleep is a microcosmic version of this cosmic quietude. It is a space where the noisy distractions of the day are stripped away, allowing your deeper self to emerge, to rest, to rejuvenate. It is a precious time for your inner universe to find its own profound equilibrium. And just as the cosmic microwave background is the gentle, lingering echo of the universe's beginning, your dreams can be the faint, beautiful echoes of your day, your hopes, your deepest desires, playing out in a softened, more symbolic form. They are not chaotic, but often follow a dream logic, a gentle, like meandering narrative guided by the subconscious, leading you through unexpected landscapes of the mind. So, as you drift now, imagine yourself as part of this grand, universal process of slowing, settling, and finding rest. Feel the warmth of your own being, a precious flicker of energy in the cosmic dance. Allow your mind to release its grip, to loosen its hold on the busy world. Let your thoughts become softer, more diffuse, like the scattered starlight blurring into a gentle mist. You are moving towards a state of profound, restorative stillness, not an emptiness, but a quiet fullness, a deep peace where all effort ceases. The world outside will continue its motions, but for now, you are invited to embrace your own inner absolute zero, to allow the gentle current of sleep to carry you away into its boundless, peaceful depths. Surrender to this quietude, to this deep, dream-filled rest, knowing that in this profound stillness, you are both completely safe and utterly renewed.